What is feature-based parametric modeling? Now that is a mouthful to spit out there. When we talk about feature-based parametric modeling, what we're saying is that all of the features that we create in Inventor are all linked to one another through parameters, and these parameters can be updated and our design will automatically change to reflect those updates. So let's take a look at that. Here I have open a part file, and all of my features are listed over here in my model browser. Now features are things like extrusions, chamfers, sweeps, revolves, placed holes, fillets. Any three-dimensional part or any three-dimensional change we make to our part is a feature. Now these are all linked together through those parameters. Now your parameters can be dimensions, size or location dimensions. They can also be geometric relationships between the shapes. So for example, this smooth arc here between this arc and the adjacent arc, these guys are tangent to one another, and that is a parameter. If you have equal spacing, so you put in an equation where you have equal spacing or you have the radius equal to one another, those are parameters. So parameters are the relationships that actually define your feature. You can see these in a part file. If you come up to the very top of your quick access toolbar, you have a little f of x symbol here, and if you hover over it, it's called parameters. You can open that up and you can actually take a look at all of the parameters that are in your file. So for my part file here, we can see that I have many parameters listed over here, and they're all labeled. As I scroll down, we can see they're all labeled with a unique label, so D74, D73, these are dimensions that were placed on here. And if we take a look over on the right here, we can see underneath equation that some of them are just static values. So these were dimensions that were placed and a value was typed in. Some of them are equations with two static numbers. So here I have D6 is 9.5 divided by 9. So you can enter them as static values, you can enter equations, you can also use other dimensions as variables in your equations. So if I take a look here at D23, we can see that D23 is equal to D14 divided by 6. D14 is 13.5 millimeters, so therefore D23 is 13.5 divided by 6. However, because we used D14 as a variable, if D14 changes, let's say it becomes 11 millimeters or 16 millimeters, then D23 will automatically update to reflect those changes. So this is what makes my feature parametric. If I was to go into my sketch and I changed one of the dimensional values, let's say I changed the radius of this arc. I'm going to change the radius of this arc to 120 millimeters. As I hit enter there, you'll notice that my entire shape has updated to reflect that. You'll notice that this dimension here, an f of x, if I open that up, we can see that this dimension is equal to D47. D47 is the one I just changed. So therefore, when I change D47 to 120, this dimension here, D69, updated to match it. So my sketch automatically updated with those parameters, and if I finish sketch, we can see that minute little change there in my part file that has automatically updated to reflect that change. So everything in this file is all linked together through those parameters, and when one of them is changed, everything that's related to that is going to update and change as well. So that is what feature-based parametric modeling in Inventor means.